The broadcast is now starting. All attendees are in listen-only mode.
All right, welcome to everybody who is joining us. Good morning, good evening, good afternoon, wherever you may be. Appreciate you joining us for this webinar. We are going to be going over what is new in InfraWorks for 2019. And we're very pleased to have Ara Ashikan presenting some of the latest features of InfraWorks. And so we'll go through a handful of those things now. Also want to thank a handful of panelists that we've got on hand as well, who can help out with some of the questions as we move along. And so if Ara is not able to get your question immediately, we have a handful of other people who will be monitoring the questions as we move along. So this is our webcast series. We have in the past been doing this a couple of times a month. We are actually going to be revising that just a bit. So now this is going to be monthly, and we'll try and hold this on the first Wednesday of each month. And we want to present to you upcoming content, new releases, things like that. And a lot of this is an opportunity for the users and the producers to really come together and discuss the things that are important to you and some of the things that we're highlighting with some of the advancements of some of the products that have come out. So next month is November 7th, we will have the next webcast. Right now we're slated to have BIM for transportation, and that's going to be a pretty exciting presentation that some of our development staff have put together for a lot of the DOTs here in the United States. And so that's a comprehensive workflow for the whole BIM process. And so you can look for those invites and some of those announcements coming up in the not too distant future. As is typical, we really want to encourage you guys to ask questions. Additionally, if you do have any sort of ideas for things to present in the future, things, your workflows or whatever it may be that is of particular interest to you, you're welcome to. In the questions poll, type that in now. We'll record that information, but also as we go along, any questions you've got, you can also enter that into the questions items as well. Want to also point out to everybody the civil community site. This is where the items will be, any of the webcasts that we've done in the past, those will all be posted here. So we've had a number of questions that have come in as far as, you know, if you were unable to attend some of these webinars, but you still want to see the content, those will all be available on the civil community site, as well as upcoming broadcasts are also going to be posted there. So you can look for that information there. As a general disclaimer, anything that's shown as future is not a guarantee that it'll be in the product. Everything I think we're showing today, though, is going to be available with the current edition of InfraWorks. So again, want to invite everyone to ask a lot of questions as we move along, and anything that's of interest to you. Again, we've got a number of panelists that are going to be helping us out with that. So again, want to thank Ara for doing the presentation, Annie for putting a lot of this together, and Elliot and Rob and a few of the others who are going to be helping out kind of on the side and behind the scenes. So as we move on, we've got a handful of poll questions, and so we will launch those now. And we'll launch these for just a few seconds for each one of these. And let me just double check. Annie, can you see everything that we've got up right now?
Yep.
Great. Okay. So we'll leave this up for just a few seconds, but just want to see what your current usage level is. And we have a handful of questions that we'll show there, and we'll just let that run for a few more seconds here. So about 5 more seconds. So you're welcome to input that. Okay. So we'll go ahead and share those results as those came in. Looks like a number of you are regular users on that. Great. So we'll go to the next question and we'll launch that, and we'll give you about 20 seconds or so to go ahead and provide answers there as well. I guess what we're looking for is, are you the main user in your company that's using InfraWorks here, or do you guys have quite a few? We'll let that roll for a few more seconds as well. Okay, thanks everybody. And so we'll share those as well. So looks like the majority of people here are in companies that are using quite a bit of that. So that's great. Okay, we've got 2 more questions here, so just bear with us as we go through some of these. The next question is interested to see what kind of work that you do with InfraWorks. And you guys can provide any kind of input there. So, and we'll let that roll for a few seconds here as well. Okay, close that down in about 3 more seconds. So, okay, great. And then the final question here, we'll hide those results, and then want to see what some of the obstacles are for implementation, if there are any. And we'll let that roll for about 10 more seconds there, and then we'll get rolling here. Great. Okay, we'll go ahead and share some of that as well. So, okay, so hopefully we can provide some resolution to some of those things that are unclear, and some of the functionality as well. So we'll get we'll move along here now to the next. And Annie, let me just double check and make sure that you do see a little city, a miniature city here. Is that correct?
Yes, you're good.
Okay. So I'm going to present just a handful of things, and these are really more functional improvements for InfraWorks, whereas ours is going to present the majority of kind of the meat and the potatoes of the presentation. So a few things that we're going to go over here are just some general functionality. And so with the home screen, there were some improvements that were made to that home menu, and some of those are just as far as opening the model. So there's some flexibility in there where the model can be opened directly as it is before, but it can also be opened in BIM 360. And so these are just a few brief videos that just kind of demonstrate some of that functionality there. Additionally, to being able to just open and run the basic maintenance and operations of opening these different models, it's also possible to create duplicate models, and those will be stored locally. And so here, this is just a brief sampling of where this information can be stored. And you can create a local copy. This is going to be ideal for anybody who doesn't have internet access or knows that they've got to work on a model that they're not going to have access to. And so that stores a local copy for anything there. And then that can be brought back in as needed. It's also possible that if a model has been removed from BIM 360, that it can be managed separately just by disconnecting that model as well. And again, this is just to improve some of the functionality, whereas some of this before wasn't quite as clear. But on these opening menus here, right on the home screen, there's some pretty keen functionality that works with the maintenance of any of your models. And then, of course, there's the ability to remove a cached model. If a model is still stored on BIM 360 and you need to remove that, if you've got some erroneous information, whatever it may be, it will remove that cache from your local drive, but it will still maintain that same model on BIM 360. So if you need to get back into it, you can do that as well. And of course, you have the ability to delete local copies completely from your machine as well. So as we move on as well, there's some different functionality that's also been made available, and that's just more with the shared views option. Typically, there would be one view that would be available, but within your model itself, you could move around and actually define and create a shared view that is going to be presented for BIM 360 or something like that. If you're actually sharing a model or it's something that's you're collaborating in the work environment, you can actually select what that preview will be there. And then one final item that I'm going to touch on are the supporting InfraWorks now it supports a number of different spiral types that are brought in with some of these different models. And right here we can just see some of the information here, some spiral to tangent and curve to spiral information. So these alignments and a lot of this alignment information is now supported more fully with the in the new version. So with that, I am going to now hand the presentation over to Ara, and let me make him the presenter now.
Thanks, Ben. I'm going to share my screen here. Can you hear me?
Yep, can hear you just fine.
Okay. So you should be seeing Bridge and Tunnel Design September 2018.
That is correct. Yep.
Okay, so let me jump in. Bit of a heads up, what am I going to be presenting today? So I'm going to be focusing on the civil structures, the bridges and tunnels, and in particular, the features that we just released a week or two ago in the 2019.2 version of InfraWorks. Now, the presentation starts with just a workflow for those who are less familiar with the steps of how you can go from early design of your civil structures towards detailed design. How do you do that? What are the steps? How does InfraWorks work with Civil 3D and Revit? How do we go beyond that? And why did we add some of the new features we did this year? So this video is going to highlight some of the features that we released in April, and but focus on the recent features. And a lot of these recent features are to allow our users to model increasingly complex projects. And even if you're designing highway bridges, for instance, even if they are short to medium span, there is a lot of geometric complexity that you need to be able to handle. So it does not mean that these are simple projects at all. And we have to develop capabilities in the workflows to allow you to address all those requirements. So I'm going to start again with the general overview of the workflow, and as we progress, we'll see more and more of what you can do. Everything in this video you'd be able to do yourselves using the latest version of InfraWorks. So there is nothing that requires any future capabilities. So let's start here. So the first thing you might do, so I selected a model in Edmonton in Canada. This is a project, it was a relatively large project a few years ago of a ring road in Edmonton, and it had a number of interchanges and a number of larger crossings. And typical of these larger design pursuits, where a team has to work in the design pursuit with many different offices, many different companies, and once they get the design, there's a lot of information to work with and to progress from concept to detailed design and construction. In this case, I just picked the example of the river crossing, and here I'm using Model Builder to create in a few minutes a starting model which aggregates from available data sources, a terrain model, aerial imagery, and so on, so that we have a starting canvas to work with in context. I should mention in passing that we have been working with our partner Esri, and the Model Builder data that we had in the past is greatly enhanced with much richer, higher quality data in the future. So similar workflows, but your starting point can be a lot more precise. So here I'm just drawing an area where I want to create the model, and here it creates in a few minutes a model. I just superimposed a picture of the actual bridges that were built. We have twin bridges over the river here, and the bridge on the left on this image has a suspended walkway for pedestrians. Otherwise, the bridges are relatively similar. So in this quick workflow, let's look at how you might be able to tackle this yourselves. So I already placed a suitable component road. A component road is a parametric road where all the lanes and sidewalks and components are dynamic, and you can change their properties, adjust them as you see fit. Now I'm placing a bridge of roughly 300 meters in length. Again, everything is dynamic and parametric. In early design, it doesn't really matter that you know the exact start station or the exact length of the bridge. You can always come back and make any changes you want. The other thing you might notice is when I place the bridge at the location along the river, it came up with a default bridge. So you don't have to create all the bridge components from scratch every time. I'm not modeling separately every pile and foundation and pier, and you start with a reasonable bridge and you modify it. In fact, we'll see later, you start with your own bridges, not this default bridge. So let's have a look at the next step. So we place this initial bridge, and I just changed the number of piers to reflect the as-built bridge with 3 piers. And then rather than having pre-stressed concrete girders, I'm going to swap those out to steel plate girder bridges, and quickly change the number of girders and to reflect the actual bridge, and also assign these to the rest of the spans in this case. Now, when we say in context modeling, that means that you can see the constraints of the site. Here, I'm going to move the pier. I'm going to rotate the pier to be exactly where I want it to be. Now, the heart of the InfraWorks-led bridge workflow allows you to quickly configure in almost real time geometries of real bridges, and the system is open-ended. So in this case, rather than using default pier that we see here, this pier has a lot of parameters. You can change the number of columns. You can decide whether the pier cap is tapered, whether its ends are rounded. It can accommodate varying depths of girders on either side, and so on and so forth. So you can build in a lot of flexibility in these components. And the whole library in InfraWorks leverages these strong modeling capabilities of Autodesk Inventor. And with Inventor, you can model really any type of pier or foundation or girder. In this case, and most users will be in InfraWorks, and when they click on a pier, they'll see in context what list of piers can I choose from. Pick the one you want and modify their parameters that are exposed on the screen to meet your requirements. In some cases, you might want to extend the system. You might want to create your own components, piers, abutments, foundations. And these can be added very easily to the system. And in large companies, most users will be consumers, and you might have a few people that create comprehensive libraries of new components so that you guys can differentiate and have exactly the type of bridge details that you want. In this case, rather than starting from scratch to create a pier, I'm actually going to load up this existing pier in Inventor directly and make a few changes. For instance, in the image that we saw at the beginning, this is the bridge which had the suspended walkway, and we need to have a bit more clearance at the pier cap. We have to have an opening there. And also the underside of the pier cap had the architectural detail. So in this step, I'm going to load up the pier directly from InfraWorks. I just go to the folder in the style palette and just open it up in Inventor. Once in Inventor, I'm just going to spend a few minutes making some changes. Let's have a look at that. So first, I'm going to change the parameter so it's kind of more closely resembles the desired layout. And then I'm going to work directly on the model. I'm going to select and create a sketch on the pier cap face and draw the geometry of the opening that I want. Notice how rather than typing in specific numerical values for the opening, I'm giving the dimensions of this sketch some names. And these are names that then can be exposed, so you have access to them from InfraWorks. And that's what we mean by a parametric component. Instead of saying the pier cap opening width is always 5 meters, you can change it from 5 to 6, whatever you need. And it's that straightforward. So here, once you have the sketch, you're going to do a 3-dimensional operation. In this case, I'm cutting through the pier cap. I'm also sketching in quick detail that I'm going to sweep across the underside of the pier, so I have the kind of architectural detail that I'm looking for. And once I'm satisfied with this, I just essentially save this pier and import it into InfraWorks. And once it's in InfraWorks, it's available in the same way as any content that Autodesk ships with the product itself. We'll see later that it's not just bridge components, tunnel components, and other components can be added to the system and be fully dynamic. Now, I just went into this updated library and picked the one that we just created. I can go and make changes to the dimensions. I can view quantities. It really doesn't matter how complex the geometry is. It will give you, at a glance, a complete breakdown of the quantities. And if you make changes to the geometry, the quantities will update and so on. Now, if you remember at the beginning, this is the as-built has twin bridges. And the second bridge is almost identical to this one, except that it doesn't have the suspended walkway. And in InfraWorks, you can create your own libraries of bridges, not just components, but once you configure this bridge, you can save this to its own library. And you can imagine yourselves having a vast library of bridges that you can reuse. And when you reuse them, you just essentially change their parameters. It might have a different number of piers and girders, but otherwise be similar. So here, I'm going into the library of bridges and pulling up the one that we just had created and make a few changes. And in a few mouse clicks, I have the second bridge, which is as per the as-built drawings. Now, at some point, the workflow in InfraWorks allows designers and bridge engineers to work with their knowledge of bridges. It's very straightforward. You can be up and running very quickly. The variables that you're playing with are basically dimensions and parameters of bridges or tunnels. How many piers, what's the spacing, and so on. At some point, we want the full BIM model so we can do construction drawings. We want to place rebar details and so on. And here we have a complete integration with Autodesk Revit. Revit, of course, it has been used for years on vertical construction. And in the civil infrastructure space, we really want to leverage very strong capabilities that Revit exposes. And creating even this bridge in Revit in the past would not be simple. Revit doesn't necessarily understand civil geometry, alignments, and horizontal and vertical profile and super elevation, whereas InfraWorks understands this and in the context of the site. Now, we created a workflow where you can dynamically create the Revit model. So you basically select a bridge and say send to Revit and create the new model. And in a few minutes, you get a complete Revit model in front of you. Now, with this Revit model, you can do plans and elevations, you can place rebar. In this case, let's go in and show elevation view of a pier and add some annotations to show some of the key elevations and dimensions on this cross section. And what we added earlier this year was the ability to, at any time, go back into InfraWorks and make changes. It might be that you started early and you have a large team in Revit doing all the drawings and the documentation of the bridge. You want this team to start early because that takes more time than creating the parametric model in InfraWorks. However, in a real world project, you will make changes as the project evolves. You might have to move a pier because there's an underground utility that you discovered, or you might have to raise a vertical profile for some reason. Many little changes, or it could be big changes. You might decide to go from 4 spans to 3 spans, or from 6 girder lines to 5 to see if you can come up with a more efficient system. So we created a workflow where you can come back and make changes to the InfraWorks model as required at any time. So here I'm going to raise the vertical profile of the road just a bit. And I'm also going to go in and maybe change some dimensions of the pier, make the pier cap 4 meters deep instead of 3,500 millimeters deep. And then when I come to, rather than creating a new Revit model, I'm going to say update the existing Revit model. And we want everyone on the team to understand who made the changes, when they made the changes, and why they made the changes. So when you say update, you have a chance to specify some comments so that the rest of the team understands these changes. Now, whoever is working in Revit at that time, or the next time they load the project, they would see that there are changes pending from InfraWorks. And should they accept these changes, the Revit model dynamically updates. And this is a huge difference from conventional workflows, wherein in the past, if we had created this project using 2D CAD, let's say we're in AutoCAD, you would have to go and make changes to a number of drawings because the vertical profile of the road changed. It would affect every elevation view, every many section views, and so on. Here, once we accept these changes, so we know who made the changes and why they made the changes, we apply these changes, and the Revit model behind the scenes updates, and wherever possible, existing annotations and rebar and so on update to the new geometry. In this case, in the background, we can see the 3,500 millimeter pier cap depth, but we changed that and we raised the road a bit. And when I apply this, you'll see that the model is going to update and the dimensions and so on will update. So huge implications on productivity here in this iterative real world scenario of going back and forth throughout the concept to detailed design stage. Now, it's not just a case of pretty pictures and quantities. Of course, as a bridge engineer, you have to carry out some analysis and to validate your design. It might be simple analysis at the beginning to validate the superstructure layout. Is it feasible to have 85-meter spans here with a 3-meter-ish girder depth? Or as you get into further detailed design, we'll be introducing much more refined analysis. We'll be opening up the analysis to work with analysis partners. But at the moment, we introduced recently the ability to carry out line girder analysis, which is a continuous beam model of the bridge, and it uses code-based distribution factors to establish moments and shears on all the girders and carries out all the code checks to validate your initial design. So let's have a look at that. So you can look at all the girders at the same time or a specific girder. In this case, we're looking at an interior span exterior girder, and we start the analysis, and in a few minutes, it's going to highlight. In this case, I use the AASHTO LRP code, but you could be using a Euro code or an Australian code, for instance. This leverages Autodesk structural bridge design on the cloud. It carries out all the computations and shows you at a glance here on the left. You can see here the shear capacity clause is failing, and the bending clauses are near unity. And at any given time, you could go in and hover over any of the girders that you studied and obtain much more detail. So here we can get a full breakdown of all the computation, and structural bridge design is very thorough with this, moments and shear diagrams and envelopes and code clauses with clear description of all the code references for all these checks. This is on as part of the workflow. As you're looking at the concepts, you might be moving piers around and playing with different girder configurations, and at a glance have this type of information available to help guide your decision making. So you can see here some of the typical design checks that you have to carry out. Again, very thorough.
Ara, we have one or two questions, and maybe you can talk about that as this is going. But the question is in regards to, and maybe some of our panelists are helping out with this, but if the girder analysis requires cloud credits, do you know in that regard?
So this is what we call the line girder analysis, and we're not requiring cloud credits for this. Call it basic early design stage analysis, so a continuous beam model. We are developing, and it's very exciting, in cases when you get into more detailed design. What if you had skewed piers or curved bridge alignment, where the applicability of a continuous beam model for detailed design is not sufficient? You'll be able to extract in real time a full finite element model, in this case of a steel plate girder or composite box girder bridge. And if you've worked on those, it can take days, if not a lot longer, to create and calibrate and use. You'll be creating those in real time as you're modeling the bridge. Our intent is to have cloud credits for these advanced analyses capabilities, but leave the line girder, which is kind of early design, just really part of the workflow with no cloud credit requirements. I'm just carrying on here. I just made a change to a transfer shear spacing, and you can see now all of a sudden in the past. Now, you're not limited to the, just looking at that. You can experiment playing with the modeling capabilities we have for girders. You can use girder slices and change any dimension along the girder and see what happens if it's variable depth. So that's enough from what we had early this year. Let's talk about what we just added. And this is the concept of generic objects. And let's introduce that with, initially we created, a release or two ago, parametric road decorations. Let's have a quick look at that, and then we'll explain how this has gone beyond road decorations into more detailed generic objects. So here, I placed the sign structure on this road. In the past, you might have a collection of SketchUp models and so on, where you'd have basically static objects that you would place along the road. But what we want is, or the users need, is the ability to place a typical sign structure and to have every one of its dimensions to be completely dynamic. So I don't want 10 of these models. I want one where I can specify what the width and the height, even the content of the sign, the text, or the diameter of the columns, or the number of anchor bolts, and so on and so forth. I want everything to be dynamic so that I can reuse this component or any other component across projects. And this is what we added with parametric decoration. So here I'm selecting it and I'm changing some of its dimensions on the stack panel in the very same way that you do with the bridge components. So again, this is saying, let's leverage content which is Inventor based behind the scenes. Now, what if we take this idea further? We mentioned this bridge here had a suspended walkway. Now, that's just bridges and tunnels will have all sorts of unique features as required. And rather than Autodesk trying to come up with a different category for every conceivable component of a bridge, it might be, in this case, it's a suspended walkway, but it might be a cofferdam for that pier. It might be all sorts of other details, seismic restrainers, and so on and so forth. What if we provided the ability for you to place dynamic objects at any location along the bridge or tunnel? And this is what we call generic objects. Generic objects are essentially three-dimensional parametric Inventor components that you choose to place along the alignment of the bridge. So here, we're going to go and right-click on the bridge and select Add Generic Object and place this suspended walkway component at a certain location, and then really have multiple, and these exposed parameters such as the geometry of the precast panels or the edge girders and the hangers. And relatively quickly, you can have what in the past we wouldn't have been able to model this because it's a bit too unique, but now it's kind of open-ended. This generic object is also going to lead the way into much more detail for steel superstructures. This is an example of a cross frame of between girders. We want this to be intelligent, so you can change as a designer, specify which configuration you want. Is it X, inverted V, and so on. You can see that geometry makes sense. Even if you were to have a box girder, everything would adjust if you had different super elevation or different configurations. We want these objects to be very, very well behaved. And this is what you can see here. So you can place these generic objects. We have plans to make it even smarter so that they automatically recognize changes to the girders and spacing. So you basically just place them where you want, and the system will automatically pass all the dimensional information they require so that everything lines up as needed. Now, we also added, incidentally, when you create this model in Revit, all this information also carries over the generic objects, sign structures, even the text on the sign, everything is there. So create your models, have all the detail you want, make it dynamic so you can reuse it over and over again. And we didn't want to limit all of this just to bridges and tunnels. InfraWorks is a broader system than that. So we added the capability to add generic objects directly to the terrain. So what if I wanted to add sheet piling here as an example in a certain location near the bridge? And now I can create really any Inventor model I want and expose any of the parameters I want to be exposed, in this case, classical sheet pile, and I can interact with it directly. I can move it around with the on-screen gizmo, rotate it, place it, change its parameters for length and height and so on and so forth, and have it available in my model. You can imagine all sorts of other things. It could be construction equipment. It could be a small dam in the model, and you want it to be dynamic and parametric, not a static mesh that you just place and use once. Here I'm going to place another generic object, which is a segmental retaining wall. Again, this is far more detailed than, say, you would do in the Civil 3D subassembly composer. This is three-dimensional geometry. You might have drainage details, all sorts of other things configured in the model. Here I'm changing the plan radius of it, and so on. So start imagining that every component of your InfraWorks project beyond the bridges can also be dynamic. Now, in the past, and we saw earlier in the video how you can create the Revit model of this bridge with the context menu. We extended that. So in this case, really, we don't want a separate Revit model for each bridge. This location or every interchange, you might have a combined Revit model. This model, the InfraWorks model, could be huge. It could be the whole city of Edmonton, whereas you want the Revit models to be maybe each interchange or river crossing. But you want to limit it. You don't want to limit it to one bridge. So we extended the send to Revit. So when you say create new, now you can see we highlight in pink all the objects which are suitable for Revit. In this case, that are based on bridges, tunnels, or generic terrain objects which have properties and parameters. So here I'm going to select the second bridge. I'm going to select the sheet pile and the retaining wall over there, and I'm going to then have one combined Revit model created. So it's the same workflow, just a lot more flexible. So you can see now this combined model with all these objects, sheet piles, and so on and so forth. And the segmental retaining wall that we're going to zoom into. Now, this part of the video just steps into, in some cases, you might start in Civil 3D, have an alignment. This is a fictitious alignment for, let's say, railway, light rail. And I want to import this or leverage this alignment in the InfraWorks model and use that to come up with my light rail bridge structure, for instance. And so here I can import, link in this alignment, and now I'm going to use the component row geometry and place the geometry along this. In this case, it's an assembly for that's reflective of light rail, and then I'm going to place a length of bridge, just 1 kilometer long, and it could be longer, but just for illustration. And if I zoom in, I'm going to go in, and I'm going to change the components of the bridge to be a bit more reflective of a light rail. And in fact, you would probably create this and add it to your own bridge library, and your next light rail project would be a collection of light rail suitable structures that you would just open up and modify as needed. Here I'm putting a guideway, box girder, and maybe a flared column and a suitable foundation. And you can see here, really in a few minutes, you have something that has quantities, it's parametric, it's dynamic, and You can again open it up in Revit. Again, the Revit model is a full BIM model. The Revit model allows you to add all the rebar details and all the construction drawings, all the IFC workflows. And here, one can just imagine how long you would take to do this directly in Revit, but as part of this overall workflow, it's very straightforward. Here we're going to select curved and planned box girder, cast in place box girder. And this is, we've worked with the Revit teams extensively over the last little while to extend Revit so it better handles the requirements of complex geometry, typical of civil structures. Rebar that follows curved geometry is what we call freeform rebar. We introduced that last couple of releases, and we keep refining those with transverse rebar, freeform capabilities. So here you can see that in the real world, you might go back to InfraWorks, or in the near future, really go back to Civil 2D and make changes and have all those changes propagate down to InfraWorks in the same way that the InfraWorks changes are handled in Revit. So here I change the alignment and maybe change the depth of the box girder, and I want the Revit model to update. Again, real world scenario that changes happen all the time in real projects, and you have to accommodate those in a way that everyone can keep track of the changes. So here we go, we had updated, everything reflects the changes. Now, parametric generic objects really open up the door. Next part of the presentation shows how you can get into much more complex geometry than what we saw earlier in that light rail structure was essentially a cast in place type of geometry. But what if you have precast segmental box girders? This is really much more complex geometry. And with generic objects, you can place, say, a component of a precast segmental box girder that has exposes the parameters that you as a designer want to control. Does it have shear keys? Does it have struts with longer cantilevers? Does it have diaphragms over the pier? All of these are dynamic parameters that you can explore. You can, of course, create your own, in this case, precast segmental box girders, and then really quickly create the geometry and the model of a much more complex bridge. And it really doesn't matter if the bridge is simple or complex. The workflow for the full BIM model is the same. You just open up the same model in Revit, and you can see here all the components of this more complex bridge are already in Revit. And if you zoom in and isolate the pier and the pier table, you can see the level of detail that we're talking about. What if you have completely different types of bridges? We couldn't do this in the past, an arch bridge. So here, let's configure just a few approach spans, and then we want to have a main span, which is a steel arch. So we created, in this case, pretty rich generic object in Inventor for the steel arch. Now, this steel arch exposes parameters such as you can control the rise of it, the width of it, the parabolic variation of the geometry, and so on. And once you're satisfied, maybe start placing in this case, a superstructure, which is a composite. It could be some other configuration, whatever you choose to place. And again, in almost real time, you can start configuring a wide range of concepts that can go to detailed design. They have quantities. Our next step on these more complex bridges is to work with our analysis partners so we can leverage all this information which is in the model to create much richer analysis models for global analysis and so on. So now you can see an instance of this arch in Revit. Needless to say, it would not be trivial to create directly in Revit, but it becomes so because in the InfraWorks workflow, Revit and InfraWorks are married together. What if you had a different type of bridge, a cable stay bridge? Here, I have a collection of piers and towers. I'm just going to use one of them from the very nice Golden Ears Bridge here in Vancouver, but I'm going to change its dimensions to be more suitable to this crossing. And I'm going to go and use generic objects to have an even more detailed component of a bridge superstructure. In this case, you can see that the Inventor model has not only the girders, but also the anchorage details. And they're all dynamic and parametric. It's kind of a mechanical level of modeling that you can do in Inventor. And here I can control the geometry and the stays the way I want them. And the generic objects can also go and open up a whole wealth of options to go into 4D construction. We will go further in the future on this, but this is just hinting at where we're going. The construction equipment, as is every component of the bridge, is parametric and intelligent. Now imagine if all of that was linked together, how you could investigate, how you're going to build this, how you're going to stage it, and so on. So a lot of interesting things coming there, but this hints at much more complex bridges that you guys can do. Again, with the release of InfraWorks from last week, all of this can be done. And creating the Revit model in this case is no different. In this case, let's put a drawing sheet together that shows maybe an elevation view and a section view and an isometric. And you might put some annotations in there. We've been leveraging the bridge parametrics to go well beyond what InfraWorks used to do for tunnels, whereas basically visualization tunnels into parametric, tunnels of quantities and workflows to Revit and so on. So here, this is a Massey tunnel location in Vancouver. I'm placing an alignment. You might import the alignment from Civil 3D, for instance, or just place it here. I'm just placing it nominally. I can change it later if I need to. I'm playing with the vertical profile, make it, of course, below the water level. And once it's configured, I'm going to go in, and instead of placing a bridge, now you have on the toolbar, you have this new tunnel icon, and you can place a tunnel. Now, the tunnels are based on parametrics that you can bring in from Inventor, very similar to, say, a complex box girder bridge. In this case, I just placed a tunnel, and I'm going to go in and grab the ends of the tunnel and kind of look at the context of the site, and I can see the aerial imagery, the portal area. I'm going to push and pull it back the way I want it. And this is a default cross section. I created a parametric tunnel section based on the as-built drawings of this tunnel, which had multiple openings and so on. And all of those have dimensions that you can vary yourselves, create your own. The ends of tunnels tend to be much more complex than two-dimensional extrusions. And so you can place portals, which are three-dimensional entities. In this case, you have struts and walls that you can configure really at three-dimensional complexity. Here we're going to place it on the other side as well, and we'll also flex some of its dimensions. Maybe make this portal a bit shorter than the other one and have fewer overhead struts where it daylights. Again, completely open-ended. In the complex tunnel, you might even have interior sections with segmental design and so on, precast panels. All of that is possible. We're going to be refining the generic objects so they become slightly more formal for tunnels and slightly more formal for precast segmental, so that they automatically understand variations of the superstructure, super elevation, and so on and so forth. These are the initial steps of allowing a much wider range of modeling. Same easy workflow, same ability to extract information out of the system and integrate with Civil 3D and Revit. So that's the overview that I have for today. I hope it sheds some light as to what you can do yourselves and the exciting direction that we're taking, where we want to go in the upcoming releases. And Ben, I turn it back to you.
Great, thanks. I appreciate it. So it looks like Austin and Elliot have been helping out with a number of the questions that have come in, but I know a couple of the questions that we had previously were in circling around Inventor. Do we know if there are any plans to include Inventor with the AEC collection?
Yeah, that's a very common question we get. At the moment, no. It's because the Inventor is the heart of the manufacturing collection. It's their kind of marquee product there. We use it in this workflow because of its very strong modeling capabilities. It's you can model much more complex geometry, and as you can see in the bridges and tunnels, we can leverage all sorts of aspects of Inventor that are frankly more suitable than modeling directly in Revit. But I should re-emphasize that for most cases, most users in InfraWorks, even those designing bridges and tunnels, are going to be using the system, and they'll have a few colleagues that might create content. So because of that, but also mainly because Inventor is the heart of the manufacturing collection, along with Fusion 360. At the moment, it's a separate edition that you have to bring into if you want to customize your bridge and tunnel, or we saw terrain generic objects.
Right, and we've got a question, but they can use Inventor LT, correct? That works for most of the items that you demonstrated, didn't it?
Yeah, so Inventor LT allows you to model what we call Inventor parts. So if it's a component like a pier that only has one material, and you're okay with having just one monolithic pier, with Inventor Pro, you can model assemblies. So if you want to have a complex multi-material foundation, or like the cable stay bridge superstructure where you have precast panels, edge girders, and these are assemblies, and the assemblies require Pro. They also, when you create the Revit model, when the components are based on assemblies, when you select, let's say, an abutment which is made using assemblies in Inventor Pro, you can sub-select every wing wall and seat and so on and ballast wall separately. As if you do it in LT, you can certainly go a long way with LT, but it's not as fine-grained, nor will it allow you to do quite as complex components. But for many users, it's a terrific starting point. And as they increase their skill set in Inventor, at some point, some of them will likely want to move up to Pro to go into more complexity.
Right. We had another question a little bit previously that was kind of in the question, do most of the updates for InfraWorks 2019.2 really revolve around the bridge? I think the GM, and correct me on this if I'm wrong, Ara, but I think that the big focus was those generic elements, but the workflow that you were showing just shows how powerful of a tool for something like bridge, but it can be used for just about anything, any other projects that they're doing, correct? As far as those generic objects.
Yeah, so the generic objects, we showed that they can be applied on the terrain now. So it could be it could be, if you want smart components along a railway, if you want to model some other civil structure besides a bridge and tunnel, it could be a small dam, it could be all sorts of secondary things like that. So the focus of InfraWorks 2019, I would say the bridge, we keep releasing multiple releases per year. It just so happens that 19.2 had a number of the bridge capabilities come to table, but we also had increased integration with Esri and other refinements on road modeling and so on. We're just highlighting, and today I lead the civil structures development teams, the bridge capabilities, but there is more in the product for sure.
Very good, very good. Okay. And so we have a few other questions. I just want to point out for everybody who is on the webinar right now, that any questions that we didn't get to, we certainly have a handful of people who have been doing a great job as far as trying to answer some of those questions, and want to again thank those guys for helping out. And we can reach out, and we will reach out for any questions that, if the question wasn't answered quite the way that you had anticipated, or if you have additional follow-on questions, we can certainly provide follow-up with that. We do have a handful of other questions just while we have a few more minutes. And one of the questions is just involved, it said the elements for the bridge superstructures, are those included in the library, or will those custom Inventor elements? I think it's a combination of both. A lot of the things that you showed today, correct? Yeah,
so a lot of this we're kind of custom built to create these models for this video. We haven't necessarily exposed all of these. We will aim in time to put more in the library, but some of these, when you create, if you look at the components that we ship with the product, they tend to be if you look at the pier, for instance, you can do all sorts of different variations of the pier. So we have to spend a bit more time to make it robust and universal enough. Some of these that I show in this video, we just modeled them enough to show the intent. So they're not necessarily ready for widespread use yet. But in time, we plan to augment our libraries a bit. But the key message is all our clients, leverage these capabilities, create your libraries, and use it as a way to differentiate, create your components, and then even save your bridges in the libraries and reuse those. And there are more benefits coming on that with even tighter integration to Revit. And this is the preferred approach.
Very good. Okay. And just a handful of the others. Or do you have access to the InfraWorks forum, correct?
Yes.
Okay. So that we have a request for questions and answers to be posted on that forum. So Austin and Elliot, who are also helping out, possibly we can organize that and just make sure that a lot of these questions get posted there for any of the follow-up there. So appreciate some of that that input from anybody else. Don't know if there's anything else there that we have to cover, but that's kind of the bulk of the presentation. Really do appreciate it. I really appreciate all your attention and detail and the presentation that we've had there. And I think with that, give everyone a couple minutes in their day. We'll end just a few minutes early, but again, want to thank everyone who participated. Thanks, Annie, for setting things up, and thanks to Elliot and Austin, who were helping out with questions as Ara was going through the presentation, and especially want to thank you, Ara, for a job well done. So appreciate it, everyone, and we look out for the upcoming invitations for some of the other webinars that are coming up in the future. And again, those will be once monthly. We'll have those on the first Wednesday of the month from this point on, and they will have similar presentations to what we had today. So thanks very much, everyone, and have a great day. Appreciate it.
All right. Thanks, everyone.